Picture London in 1675. The mighty British Empire faced a critical challenge that threatened its maritime supremacy. Ships vanished in vast oceans, merchant vessels strayed off course, and countless fortunes were lost to the unforgiving seas. All because of one fundamental problem: navigation errors. In the midst of this maritime crisis, King Charles II made a decision that would forever transform how humanity measures time and space. Within the opulent halls of Whitehall Palace, the king summoned a brilliant young astronomer, John Flamsteed. With the weight of the empire's future in his words, Charles II issued a command that would echo through centuries: find a way to make our ships navigate with precision. The story that unfolded wasn't merely about constructing an observatory. It was the beginning of a scientific revolution that would establish how the entire world measures its position to this day. This humble building, perched atop Greenwich Hill, would become the focal point from which all global coordinates would be measured. As the British ships battled treacherous waters and uncertain positions, Flamsteed and his team embarked on an ambitious mission to map the stars with unprecedented accuracy. Their work would eventually lead to the creation of the Prime Meridian, the invisible line that divides our planet into east and west, and the establishment of Greenwich Mean Time, the standard by which the world would synchronize its clocks. Today, every time you check your smartphone's GPS, plan an international journey, or simply wonder what time it is somewhere else in the world, you're connecting with a legacy that began with a king's command and an astronomer's dedication on that fateful day in 1675. If you're fascinated by how moments like these shaped our modern world, make sure to subscribe to Modern Age Chronicles and hit that like button. Join us as we explore more pivotal moments that transformed human history. Remember, understanding our past helps us navigate our future. Support our journey through history, like this video, and subscribe to Modern Age Chronicles, where the past comes alive to illuminate our present. Let us meet the remarkable individuals who shaped one of history's most significant scientific endeavors. These pioneers of astronomy and their complex relationships would forever change how we understand our position in the world. John Flamsteed, the first Astronomer Royal, was far more than just a stargazer. Born in Derbyshire in 1646, this brilliant yet uncompromising man devoted his life to the pursuit of astronomical precision. Despite suffering from poor health since childhood, Flamsteed would spend countless sleepless nights meticulously documenting the heavens. His obsession with accuracy often put him at odds with his contemporaries, but his dedication resulted in the most comprehensive star catalogue of his time. Working with instruments he largely funded himself, Flamsteed would eventually document over 3,000 stars with unprecedented accuracy. King Charles II, often called the Merry Monarch, proved there was more to him than his reputation for hedonistic pursuits might suggest. After the near-catastrophic loss of his fleet due to navigational errors, Charles II demonstrated remarkable foresight by investing in scientific advancement. The king, who had spent years in exile in France and witnessed their scientific progress, understood that Britain's future as a maritime power depended on solving the longitude problem. His decision to establish the Royal Observatory marked a crucial turning point in British scientific history. Robert Hooke, a scientific genius and one of the most versatile minds of his time, brought his architectural expertise to the observatory's creation. Already famous for his microscopical observations and his law of elasticity, Hooke designed a building that was both functional and economical. However, his relationship with Flamsteed was often strained by professional rivalry and conflicting personalities. Despite these tensions, Hooke's practical design, completed in just 6 months with a modest budget of £520, proved remarkably suitable for astronomical observations. Edmund Halley, who began as a young assistant at the observatory, would later emerge as one of history's most celebrated astronomers. His early work at Greenwich helped establish the foundation for his later achievements. Though initially working under Flamsteed, their relationship became increasingly tense as Halley's own star rose in the scientific community. His most famous achievement, predicting the return of the comet that bears his name, was still years away, but his time at Greenwich proved invaluable to his development as a scientist. These 4 men, despite their differences and occasional conflicts, each played a crucial role in establishing Greenwich as the world's premier astronomical institution. Their combined efforts, driven by both competition and collaboration, would help solve one of the age's most pressing problems: accurate navigation at sea. Though they might not have fully realized it at the time, Their work would eventually lead to Greenwich becoming the global standard for measuring time and position, a legacy that continues to influence our lives today through modern technologies like GPS and international time zones. Transport yourself to London in 1675, a city on the cusp of scientific revolution amidst the grime and grandeur of the Restoration era. The London you would encounter is a far cry from the metropolis we know today. The air hangs heavy with the acrid smoke of sea coal, the city's primary fuel, billowing from thousands of chimneys. Through narrow, cobblestone streets, iron-wheeled carts and carriages clatter against the stones, creating a constant symphony of urban life. The River Thames, the lifeblood of London, teems with vessels of all sizes, from humble fishing boats to magnificent royal barges. But our story draws us away from the crowded streets of the city proper, downstream along the Thames to Greenwich. Here, atop a magnificent hill stands Greenwich Palace, where Tudor monarchs once held court. The hill itself, rising 150 feet above the river, offers a commanding view of the serpentine Thames and the bustling maritime activity below. On this strategic elevation, a remarkable scene unfolds. A group of workers, supervised by some of England's finest scientific minds, labors to construct what will become Britain's first state-funded scientific institution. The location has been chosen with utmost care. High enough to escape London's notorious pea-soup fogs and smoke, yet close enough to maintain regular communication with the royal court at Whitehall, Greenwich Hill provides the perfect vantage point for astronomical observations. The construction site itself tells a story of resourcefulness. The building materials include stones recycled from the ruins of Greenwich Castle, a medieval structure that once crowned this hill. Local workers, many of them skilled craftsmen from the nearby shipyards, apply their expertise to this unique project. The design, though modest in scale, is purposeful, every aspect calculated to serve its astronomical mission. From this elevated position, one can see the masts of countless ships dotting the Thames, a constant reminder of why this observatory is so crucial. Each vessel represents lives and fortunes at stake, all dependent on solving the pressing challenge of accurate navigation. The sea air carries the mingled scents of tar, rope, and the brackish river, while seabirds wheel overhead against the ever-changing English sky. As the walls rise day by day, curious onlookers from the nearby town of Greenwich gather to watch. They're witnessing the birth of an institution that will one day become the reference point for how the entire world measures time and position. The meridian that will eventually pass through this spot remains unmarked and unknown, yet destiny is already at work on this historic hill. This is not just a construction site, it's the foundation of a new age of scientific discovery, rising from English soil to reach for the stars. The very air seems charged with possibility, as if the future itself is being built stone by stone atop Greenwich Hill. At the heart of Greenwich Observatory's creation lies a tale of maritime crisis, royal intervention, and scientific triumph that would ultimately reshape how we navigate our world. In the late 17th century, the seas were claiming an alarming number of ships and lives. The fundamental problem was simple yet devastating. Sailors could not accurately determine their position at sea. While calculating latitude was relatively straightforward using the stars, longitude remained a mystery. Ships would often find themselves hundreds of miles off course, leading to catastrophic accidents, lost cargo, and countless deaths. The British Empire, with its growing dependence on maritime trade, faced an existential threat. In 1707, the tragic loss of 4 warships and 1,400 sailors off the Isles of Scilly highlighted the desperate need for a solution. King Charles II, deeply troubled by these maritime disasters and their impact on British power, made a bold decision. In 1675, he signed a warrant establishing the Royal Observatory, appointing John Flamsteed as the first Astronomer Royal. The mission was clear: create accurate star charts and develop methods for precise navigation. This marked the first time a European monarch had funded a purely scientific institution, setting a precedent for state-sponsored research. What followed was an extraordinary feat of efficiency. Under Robert Hooke's direction, the observatory rose from Greenwich Hill in just 6 months, a remarkable achievement for the era. Working with a modest budget of £520, equivalent to roughly £100,000 today, the builders incorporated stones from the demolished Greenwich Castle. The building's design was purposefully practical, featuring a unique octagonal room that would house the primary instruments. Flamsteed's early years at the observatory were marked by relentless dedication and numerous challenges. Working with largely self-funded instruments, he began the painstaking process of creating the most accurate star catalog ever attempted. Every clear night, he would record stellar positions with unprecedented precision. These observations would later prove crucial for developing reliable navigation methods. Over the following decades, the observatory's reputation for accuracy and scientific rigor grew steadily. Ships' captains increasingly relied on Greenwich's astronomical data for navigation. The development of precise chronometers by John Harrison, combined with the observatory's stellar observations, finally offered a reliable solution to the longitude problem. Greenwich gradually became the unofficial reference point for British maritime navigation. The observatory's transformation into a global standard reached its pinnacle at the International Meridian Conference in Washington, D.C. in 1884. Representatives from 25 nations gathered to establish a single prime meridian for the entire world. Greenwich was chosen as the global zero-degree longitude, largely due to its established reputation and the fact that nearly 72% of the world's shipping already used Greenwich as their reference point. This decision established Greenwich Mean Time, GMT, as the global time standard, a system that remains fundamental to international timekeeping and navigation today. This progression from a national crisis to global standard represents one of history's most successful scientific initiatives. The observatory's influence extends far beyond its original maritime purpose, touching everything from modern GPS systems to international time zones. If you're fascinated by how crucial moments like these shaped our modern world, make sure to subscribe to Modern Age Chronicles. Hit that like button to help us share these remarkable stories with a wider audience. Join us at Modern Age Chronicles, where we uncover the extraordinary events that created the world we know today. The early observatory's arsenal of scientific instruments represented the cutting edge of 17th century technology. The primary instrument was the mural quadrant, a massive device fixed to the meridian wall, used to measure the angular height of celestial bodies. Flamsteed's original quadrant, spanning 6 feet in radius, allowed measurements accurate to within 10 arc seconds, remarkable precision for its time. The zenith sector, another crucial instrument, measured the exact moment when stars passed directly overhead. This was complemented by the transit instrument, which determined precisely when celestial bodies crossed the meridian line. These observations were timed using pendulum clocks, the most accurate timepieces of the era. Perhaps most innovative was the observatory's camera obscura, housed in the iconic octagon room. This dark chamber projected images of the sun onto a screen, allowing safe and accurate solar observations. The room's large windows were strategically placed to maximize observational opportunities. The longitude problem was the greatest scientific challenge of the age. While sailors could determine their latitude by measuring the height of the sun or Polaris above the horizon, longitude proved far more complex. The fundamental issue was time. To know your longitude, you needed to know the precise time at both your current location and a reference point, eventually Greenwich. The mathematical principle was straightforward. The Earth rotates 15 degrees every hour, so by comparing local time, easily determined by solar observation, with the time at a reference location, one could calculate longitude. The challenge lay in keeping accurate time at sea, where ship motion, temperature changes, and humidity played havoc with timepieces. The breakthrough came with John Harrison's remarkable chronometers. After decades of work and 4 major prototypes, H1 through H4, Harrison created timepieces that could maintain accuracy within seconds over months at sea. His H4 chronometer, completed in 1759, was a masterpiece of precision engineering, incorporating bimetallic strips to compensate for temperature changes, anti-friction caged roller bearings, a novel grasshopper escapement design, superior lubricating materials. Harrison's innovations revolutionized maritime navigation and earned him Parliament's £20,000 prize for solving the longitude problem. His work laid the foundation for modern precision timekeeping. The establishment of Greenwich Mean Time was a gradual process that revolutionized global timekeeping. Before GMT, each town kept its own local time based on the sun's position. This created chaos for the emerging railway networks and international commerce. The observatory began providing time signals to ships in 1833 using a time ball, a large wooden sphere that dropped at precisely 1 p.m. each day. This system allowed ships on the Thames to calibrate their chronometers accurately. By 1847, Greenwich time signals were being transmitted via telegraph across Britain. The scientific method for establishing GMT involved daily transit observations of stars, precise pendulum clock calculations, regular calibration checks, time signal distribution systems. GMT became Britain's legal time standard in 1880, and by 1884, it was adopted as the global Prime Meridian at the International Meridian Conference. This system created the foundation for our modern time zones and Coordinated Universal Time, UTC. The remarkable precision achieved by these early instruments and methods laid the groundwork for modern navigation and timekeeping systems. Today's atomic clocks and GPS satellites are the direct descendants of these pioneering efforts at Greenwich. The adoption of Greenwich Mean Time, GMT, as the world's time standard marked a profound transformation in human civilization, reshaping nearly every aspect of life across the globe. Before GMT, time was a local phenomenon, with each city or town operating on its own solar time. The move to a unified time system brought with it a revolutionary change in how people across the world coordinated and interacted, especially in areas like international commerce, global communications, transportation, and scientific collaboration. The ability to standardize time allowed for precise scheduling, made trade across continents more efficient, and helped synchronize telegraphic messages worldwide. Railways and shipping lines could now adhere to reliable timetables, improving the consistency and reliability of global travel and trade. For scientists, having a common temporal reference greatly facilitated collaboration, enabling researchers around the world to align their observations and findings. One of the key areas transformed by the adoption of standardized time was maritime navigation. The combination of accurate astronomical observations and precise chronometers revolutionized seafaring, reducing shipwrecks and lost cargo significantly. This technological leap led to faster and more efficient trade routes, improved naval military operations, and the ability to chart and map the world more accurately. Passengers could now travel across oceans more safely, and the growth of maritime insurance became more reliable with the ability to calculate risk with greater precision. The era of exploration and empire building saw marked improvements in navigation, which made long voyages safer and more predictable. The development of the British Empire was deeply influenced by the contributions of Greenwich, particularly in terms of naval dominance. The precise navigation capabilities enabled by GMT and the advancements in chronometers gave the Royal Navy a strategic advantage, allowing Britain to control the seas and expand its global empire. Accurate navigation also enhanced colonial administration and trade by providing a means to govern vast territories spanning multiple time zones. As British maritime dominance grew, so too did the global influence of the English language, particularly in commerce. The prestige of the Greenwich Observatory helped cement Britain's position as a leader in both scientific and cultural spheres, giving the country a considerable advantage in the global arena. Time standardization further facilitated governance across the empire, ensuring that military operations, trade, and communication ran smoothly, regardless of the time zones in which the colonies operated. The 1884 International Meridian Conference marked a milestone in global timekeeping by establishing a system that still governs how the world organizes its time. The conference divided the world into 24 time zones, created the international date line, and laid the groundwork for universal coordinates used in global mapping. This conference also standardized international navigation and facilitated synchronized global communications. The decision to place the Prime Meridian at Greenwich, London, not only solidified Britain's dominance in global affairs, but also provided a uniform standard that would be used by all nations for the purposes of navigation, trade, and communication. Greenwich's influence continues to extend into contemporary technology in ways that are integral to our modern world. The Global Positioning System, GPS, for instance, relies on Greenwich as the reference for zero longitude, and position calculations continue to use Greenwich as the prime meridian. GMT's successor, Coordinated Universal Time, UTC, remains the standard for time measurement worldwide. Digital communications, too, depend on synchronized time measurements. The Internet, financial transactions, and international air traffic control systems are all based on precise time coordination rooted in Greenwich. These systems rely on accurate timekeeping to function effectively, ensuring that the complex global systems we take for granted remain operational and efficient. The legacy of Greenwich extends into space exploration, where astronomical navigation systems and satellite orbital calculations depend on the same principles established by the observatory. The International Space Station's operations, satellite communications, and meteorological services, such as weather forecasting, climate monitoring, and natural disaster prediction, are all influenced by Greenwich time standards. Even in the world of mobile technology, smartphone time synchronization, location-based services, and international roaming capabilities rely on the global time framework pioneered by Greenwich. The influence of Greenwich Mean Time stretches across numerous modern fields, including international business, scientific research, and entertainment. In business, the synchronization of global market opening and closing times, the scheduling of international conferences, and the coordination of multinational operations are all made possible by standardized time. In the realm of scientific research, standardized timing for experiments and international collaboration are made easier, while data collection from around the world can now be synchronized effectively. The sports and entertainment industries, too, depend on time standardization for global broadcast scheduling, coordination of international sporting events, and streaming service time management. Environmental monitoring, including studies of climate change, ocean currents, and migration patterns, also relies on precise, globally synchronized time measurements. The Greenwich Observatory's legacy continues to evolve with new technologies, demonstrating how a 17th-century institution remains relevant in the digital age. Its fundamental principles underpin much of our modern global infrastructure, from the internet to space exploration, ensuring that the world's intricate systems of communication, navigation, business, and research operate seamlessly across time zones. The ongoing influence of Greenwich is a testament to how time, once a localized concept, has become a key element in the coordination and functionality of our interconnected world. The Greenwich Observatory's initial budget of £520, an amount equivalent to approximately £100,000 today, may seem modest for an institution that would later become a cornerstone in global navigation and timekeeping. This limited funding, however, spurred remarkable innovation. The architects had to be resourceful, utilizing materials creatively and adapting techniques from shipbuilding to ensure the project's efficiency. The workforce maximized every penny spent, squeezing the utmost value out of every resource available. Despite the financial constraints, the completion of the observatory was an extraordinary achievement, showcasing the power of ingenuity in overcoming limited resources. One of the most fascinating aspects of the observatory's construction was its use of recycled materials. The stones from Greenwich Castle, a medieval fortress, were repurposed in the building of the observatory, turning remnants of a past era into the foundation of scientific progress. Each stone, once part of a fortress designed for defense, now supported a structure dedicated to the exploration and understanding of the universe. This practical decision not only helped reduce construction costs, but also created a symbolic bridge between the ancient and modern worlds, marking the transition from the medieval age to the dawn of scientific discovery and global coordination. John Flamsteed, the first Astronomer Royal, demonstrated extraordinary dedication to the mission of the observatory. His personal investment in the success of the project was immense. He funded many crucial instruments from his own pocket and spent countless nights making meticulous observations of the stars. Flamsteed manually calculated and recorded over 3,000 stellar positions, creating the most accurate star catalog of his time. His work was so precise that many of his observations remain accurate by modern standards, cementing his place in the history of astronomy as a pioneer of accurate and systematic celestial measurement. The Prime Meridian line, the brass mark set at 0 degrees longitude in the observatory's courtyard, has become an iconic symbol of global geography. It physically represents the division between the eastern and western hemispheres. Visitors from across the globe come to stand with one foot in the east and the other in the west, making it a unique experience for travelers and geography enthusiasts alike. The Meridian line continues to stretch northward through the British countryside, visible on satellite imagery, and forms an essential part of the global navigation framework that governs international mapping and timekeeping. The observatory's influence extends far beyond historical study, touching nearly every aspect of modern life. Its legacy is evident in the systems that underpin our everyday activities, especially in the realm of technology and communication. In smartphone navigation, every GPS coordinate reference traces back to Greenwich, with navigation apps relying on Greenwich-based calculations. Time synchronization for mobile devices around the world follows the Greenwich standard, ensuring a seamless connection for global users. For air travel, flight paths are calculated using Greenwich-based coordinates, and international arrival and departure times are coordinated according to GMT. Aviation weather forecasting is also synchronized to Greenwich time, ensuring that pilots and air traffic controllers are aligned across time zones. In digital communication, the influence of Greenwich is equally profound. Internet protocols rely on precise time measurements set by Greenwich Mean Time. International video conferences spanning multiple time zones are seamlessly coordinated through the synchronization of global time standards. Furthermore, global financial transactions are timed to the microsecond, ensuring that markets around the world operate efficiently and fairly. The reality that visitors can physically stand across two hemispheres at Greenwich highlights the modern understanding of global positioning. For those who visit, the experience of straddling the east and west is both symbolic and meaningful. Photos taken at the Meridian line are treasured souvenirs, representing the unique connection between physical geography and the abstract concept of global time. Scientifically, the Meridian line illustrates the arbitrary but necessary division of the Earth into time zones. It demonstrates the importance of having international standards, particularly in an age when global cooperation and precise coordination are critical. It's a reminder of how abstract concepts, such as time and longitude, become physical realities that shape our world. Greenwich's legacy continues to influence modern technology, ensuring its relevance in today's rapidly evolving fields. In space exploration, the principles established by the observatory remain integral to satellite navigation systems, interplanetary mission planning, and space station orbital calculations. As humanity ventures deeper into space, Greenwich's role in coordinating time and positioning will continue to play a crucial part in ensuring the success of these missions. In environmental monitoring, the observatory's legacy lives on through climate change studies, ocean current tracking, and weather pattern analysis. These fields depend on accurate timekeeping and global positioning systems, which trace their origins back to the Greenwich Observatory's innovations. In the realm of digital technology, Greenwich's time standards influence blockchain timestamp verification, 5G network synchronization, and coordination across the Internet of Things, ensuring seamless communication between devices and systems. The remarkable aspect of Greenwich's legacy is how an institution designed to solve 17th-century navigation challenges continues to be a fundamental part of our modern technological infrastructure. From quantum computing to space exploration, the observatory's principles remain embedded in the systems that govern our global interconnectedness. Greenwich stands as a testament to the enduring value of scientific standardization, international cooperation, and the far-reaching impact of innovation. If you're fascinated by the connections between historical innovations and modern technology, don't forget to subscribe to Modern Age Chronicles and like this video. Help us continue exploring these amazing links between past and present. Join us at Modern Age Chronicles, where history's influence on our daily lives becomes clear.